For the second part of section 9.4, we're going to multiply rational expressions. So since rational expressions look like fractions, we multiply them just like we multiply fractions. So we are going to multiply across the numerators and the denominators. So as an example, let's say we have 3 over 4 times 5 over 6. So if we multiply these, we go across the numerators. So 3 times 5 is 15. And across the denominators, so 4 times 6 is 24. And then we always simplify. So if we reduce this, we can reduce this by 3 because 3 goes into both 15 and 24. So we're going to divide by 3, divide by 3. 15 divided by 3 is 5, and 24 divided by 3 is 8. So our final answer, simplified, is 5 over 8. All right, so let's look at these examples. So these are monomial rational expressions. So they're not polynomials. They just have one term each. So when we do this, first thing we're going to do is multiply right across the numerators. So this times this. So why don't I start up here? So we have 5x squared y times 6x cubed y squared over, and then across the numerators, we'll have 2xy cubed times 10y. So I haven't really done anything yet. I just multiplied across the denominators and multiplied across the numerators. So now we need to think about simplifying. So first of all, I can simplify within this numerator. So first, let's multiply these two coefficients. So we've got 5 times 6. That's going to give us 30. And then we have x squared times x cubed. So since it's times, since it's multiplication, we add the exponents. So x to the 2 plus 3 power. And then we have y to the first times y squared. So that's going to be y to the 1 plus 2. So see how we need to remember all of these exponent rules? So then in the denominator for the coefficients, we have 2 times 10, which is 20. Then we have x to the first, and that's the only x we have, so it's just x. And then we have y to the third times y to the first. This is times y to the 3 plus 1. So then simplifying those exponents, we'll have 30x to the fifth, y to the third, over 20x y to the fourth. Now, let's simplify. So first of all, 30 over 20, actually, let's think about it this way. Let's think about it by taking out GCFs. So I can factor out a 10 out of both the top and the bottom. Now I know that because 10 goes into both 30 and 20, so I can factor a 10 out of both the top and the bottom. Now let me look at the x's. So we have x to the fifth in the top and x to the first in the bottom. So I can factor out an x from both the top and the bottom, right? Since both of these have at least one x. Now we have y cubed and we have y fourth, which means I can take out a y cubed. It's always the lower one, lower degree, so I can take a y cubed out. All right, so then what am I left with? So if I factored a 10 out of this 3, I'm left with 3. Okay, we factored one of these x's out, so that leaves me with x to the fourth. And then we factored out a y cubed, so that we factored out this entire y. And then in the bottom, we factored a 10 out of this 20, so I'm left with 2. We factored this 1x out, so that's gone. And then I factored out y cubed from this y to the fourth, so I'm left with 1y. Now this is just like reverse distribution here. So if you want to check that we're correct, factor this 10, so distribute this 10 into the 3, and we get 30. The x times x to the fourth gives us x to the fifth, and then y cubed all by itself gives us y cubed. In the denominator, 10, distribute it to the 2, and we get 20. X is all by itself, so we just have an x. And then y cubed times y to the first gives us y to the fourth. So that tells me that we factored this correctly. And the reason we did it this way, so we found a GCF in the top and the bottom. And the reason is that we can now cross that out, and we're just left with 3x to the fourth over 2y. And that's it. So let's do the next example. If you missed anything on that, you might want to back up in the video and watch it again, see if you can figure out what you missed. But we'll do the next example. It's really similar, so hopefully if you did kind of miss out on something, this will make a little more sense. So we're going to do the same steps. I'm going to like cross that out just so we're not looking at that because I want to start this over here. So we've got 80x to the fourth times xy, so multiplying across the numerators. And then we have y cubed times 5x squared, multiplying across the denominators. So that's step one. Just multiply across the numerators, multiply across the denominators. Now we want to simplify the numerators and the denominators. So this is equal to 80. We have x to the fourth times x to the first. So add the exponents and we get x to the fifth. And then the y is all by itself, so we just have y. Then in the denominator, I put my coefficient out front. So we just have a 5 for the coefficient. And then for the x's, it's just x squared. Then for the y's, it's y cubed. All right, so that part wasn't too crazy. Now we need to kind of see if we can factor out a GCF from the top and the bottom. So let's look at the coefficients first. So we have 80 and 5. Ask yourself what goes into both 80 and 5. The answer is 5. So that means I'm going to factor a 5 out. If you want, you can already start on what's going to go inside the parentheses. So 5 times what is 80? Well, you do 80 divided by 5, and you get 16. So 5 times 16 is 80 in the numerator. And then 5, well, we only need a 5, so it's just 5 times 1. So you can write the 1 if you want, or you can just leave it blank there. Then let's look at the x's. So we have x to the fifth in the numerator, x squared in the denominator. GCF there, it's always the lowest degree. So we pick x squared, we factor that out. Okay, so if we factor out an x squared in the numerator, if we take 2 away from 5, we're left with x cubed. And in the bottom, if we took out an x squared, once again, we only took out one of those. So you can write the 1 or you can leave it blank. Now, if you had written both 1s, you would now have 1 times 1, which is still 1. So up to you if you want to write that or not. I'm going to not write it because that's my preference. But I know some of you do like to write that. So then in the top, we have, we're looking at the y's now. So we need to figure out what we can factor out of both of these y's. It's always the lower degree, so it's y to the first. So we're going to take out a y to the first. And since we only have a y to the first up here, that's it. So nothing left. Again, if you want to write the times 1 in here, you can. Then in the denominator, we'll have y here. And if we take out one of these y's, we're left with y squared inside here. And again, reason we do that is because now we can cancel out these things we factored out, and we are left with 16x cubed over y squared. The end. Okay, so next one. Now these are polynomial rational expressions. So those were monomials that we were dealing before. These have multiple terms. So the way we're going to do this is we are going to multiply across the top, but I want to put parentheses around everything to keep myself organized. So we have 4x minus 4x squared times x squared plus x minus 6. Keep them in parentheses over x squared plus 2x minus 3 times 4x. Now there's a reason I'm doing that. The reason is that we want to treat these as separate polynomials because I'm going to factor each of these set of parentheses. So let's look at this first. So the 4x minus 4x squared. Let's circle that in blue. So we're going to factor our blue polynomial here. The only thing that I can see I can do here is factor out a GCF. So these both have a 4 in common. So I'm going to factor out a 4, and then we have an x to the first and an x to the second. So I'm going to take out an x to the first. And then I'm left with, if we factored out a 4x from this 4x, we're left with 1 minus x. So if you think about it, redistribute, you would have 4x minus 4x times x, which is 4x squared. All right, so we factored that now. Let's do this guy in green. Let's factor that. So this is a trinomial. So I want to ask myself, what adds to 1 that multiplies to -6? That's going to be x plus 3, x minus 2. 3 minus 2 is 1. 3 times -2 is -6. All right, all of this over. New color, let's do this color, purpley pink. And let's factor this guy down here. So this is another trinomial. So we want to know what adds to 2 that multiplies to -3. Our answer is x plus 3, x minus 1 is 3 minus 1 is 2. 3 times -1 is -3. And then that 4x, I can't factor that. So I'm just going to leave it as 4x like that. So now something sort of interesting has happened here. We've got everything as factored as it can be, which means now we need to see if we can match up any factors to cancel out. So you can only cancel things out if you have factors that are exactly the same. So let's go one by one and look through them. So let's start with this 4x. This is our first factor, the 4x. So we need to ask ourselves if there is a factor of 4x in the denominator, and there is. We have a 4x and a 4x, so those are gone. Now we have a factor of 1 minus x. We need to see if we have the exact same thing in the denominator. Currently, no, we don't. Actually, not just currently, we don't. So 1 minus x is not the same thing as x minus 1, so be careful. Those are not the same. You can't cross them out. So moving on to the next one, we've got x plus 3, and look at that. We've got an x plus 3 in the denominator. And then we have x minus 2. Don't have that anywhere. So that means our final answer here is everything we're left with. So this equals 1 minus x times x minus 2 over x minus 1. And you can leave it like that. If you want to simplify the numerator, go for it. You would need to FOIL those, but you don't have to. This is fine. So just backing up, looking at our steps here, we have to factor everything. So multiply these together. Leave your polynomials in parentheses, then factor each set of parentheses and cross out any like factors in the numerator and denominator. So let's do another one. So step 1 is to multiply. So we want to keep everything in parentheses. So we have x squared minus x minus 6 times x plus 1 over 4x cubed times x squared plus 5x plus 6. All right, so step 1 is to just multiply across the top and the bottom. Now we need to simplify. So the way we're going to simplify, let's start with this guy here. We're going to factor that. So what adds to -1 that multiplies to -6? X minus 3, x plus 2. -3 plus 2 is -1. -3 times 2 is -6. And then that x plus 1 up there, I'm going to leave that in red because I can't factor that. Then we've got a 4x cubed. I can't do anything with that either, so I'm actually just going to leave it as is. Put it in parentheses. And then this guy right here, we can factor that. That's a trinomial, so let's factor that. We want to know what adds to 5. That multiplies to 6. X plus 2, x plus 3. 2 plus 3 is 5. 2 times 3 is 6. So now that we have factored everything, let's see if we can find our like factors in the numerator and denominator. So we have x minus 3. I don't see an x minus 3 down here, so let's move on. X plus 2, yep, we've got another one down here. Then we have x plus 1. I do not see an x plus 1. So that means we move on. That's all we got. So x minus 3, x plus 1, 4x cubed, x plus 3. The end. That's it. Last thing. So if you're multiplying by a polynomial, this actually is not a whole lot different than what we just did because you're going to do one tiny little step right before. This is just like, say we're multiplying 3/2 times 4. What do we do here? Well, usually we just put the 4 over a 1, and then we've got two fractions. So 12 over 2 equals 6 over 1, which is 6. So the idea here is that we're putting this whole number over 1. So it's the same thing here. So when we've got a rational expression times a polynomial, you just want to put the polynomial over 1. And now it's two rational expressions. So you multiply the numerators. So we've got x plus 3, 2x minus 1, and then multiply the denominators. 8x cubed minus 1 times 1. You don't need to write the times 1, but if you want to, you can. And then we factor. So the numerator, we can't factor that at all. X plus 3 can't do anything with that. 2x minus 1 can't do anything with that. So I'm just going to rewrite it. All right, the denominator is something that we're going to need to refresh our brains on, difference of 2 cubes. So let's do this over here. So difference of 2 cubes. So we have 8x cubed minus 1. A is equal to the cube root of 8x cubed. Cube root of 8 is 2. Cube root of x cubed is x. B is equal to the cube root of 1, which is 1. So then when we factor this, it is a minus b times a squared plus ab plus b squared. So that means our denominator is now, so this guy right here is now a minus b, so 2x minus 1 times 2x squared, which is 4x squared, plus 2a times b, which is 2x times 1, plus b squared, which is 1. And then we look for our like factors, x plus 3, don't see that anywhere, 2x minus 1 cancels with 2x minus 1. And then we're just left with, for our final answer, x plus 3 over 4x squared plus 2x plus 1. And that is that. Let's do this last example here. So I'm going to erase this. Make some room. Whoa, what happened? Okay, that was weird. Erase this, make some room again. If you got lost on anything when we were doing that, please go back and watch it. Perhaps watching it a couple times and thinking about it will help you kind of figure out whatever you were missing first time around. All right. That is good enough. So let's do this one. So put this over 1, multiply the numerators. So we have 2x squared minus 2 times x squared minus 10x plus 21 over x squared minus 6x minus 7. This is going to be a lot of factoring here. So for that first one, 2x squared minus 2, let's see what we can do with that guy. So I'm going to factor out a GCF from that. So let's circle this in this color. So 2x squared minus 2. I'm going to factor out a GCF. So this is equal to. So we have a 2 and a 2, which means I can take out a 2. Then we're left with x squared minus 1. That's interesting. We'll get to y in a minute in the next step. So this right here, x squared minus 10x plus 21 is a trinomial. So we want to know what adds to negative 10 that multiplies to 21. And that would be x minus 7 and x minus 3. Negative 7 negative 7 plus negative 3 is negative 10. Negative 7 times negative 3 is 21. Let's look at the denominator. We've got another trinomial. We want to know what adds to negative 6. That multiplies to negative 7. Let's do that in green. So this guy right here adds to negative 6. That multiplies to negative 7. Well, there's only one. 7 only has two factors, 7 and 1. So it's got to be x minus 7, x plus 1, because negative 7 plus 1 is negative 6. Negative 7 times 1 is negative 7. All right, so let's take a look at what we can cross out here. So we've got a 2, not much to do with that. X squared minus 1, not much to do with that yet. X minus 7, we'll look at that. We can go like this and that because we have an x minus 7 in the top and the bottom. X minus 3, don't see that anywhere. All right, so now we've got something neat. This guy right here, the x squared minus 1, is a difference of two squares. So I can factor that as x plus 1, x minus 1. And then we have, I'm going to do the rest of this in red, x minus 3 over x plus 1. So all I've done in this step was I got rid of this x minus 7 factor that we canceled out, and then I factored this. The x squared plus 1 is x plus 1, x minus 1, because it's a difference of two squares. And the reason that's good is because now we have one more thing that we can cancel out because we've got an x plus 1 and an x plus 1. So we would not have caught that if we didn't do the difference of two squares. So now we have 2, x minus 1, x minus 3 over 1, because we factored out we canceled out the only factor. So it's over 1, and we know that anything over 1 is just the numerator. So we're left with 2 times x minus 1 times x minus 3. And that is it for part 2 of this section. The good news for you for next time is that part 3 is extremely similar to part 2. So really take the time to make sure you understand what's going on here. And that's it for today.